We go now to Simport system. You say Simport system uses the downhill movement of one solute or one ions from high to low concentrations to move another molecule uphill from low concentration to higher concentration against its electrochemical gradient. So usually when you say electrochemical gradient, this refers to the different solutes with electrical charges. Okay, so example, glucose importer SGL1 or SGLT1, which co-transport one glucose or even galactose molecule into a cells by for every 2 sodium ions it imports into the cells. So usually if you try to see, this is the anti-port system. Okay, it was discussed a while ago that the movement is considered to be at opposite directions. So once sodium is released, then there is 2 sodium ion that will guide the glucose, because the movement of glucose from the extracellular environment of cells is considered to be sodium dependent. So usually both molecules have the same directions. So take note that the transporter for glucose is glucose, importer SGLT1. So the movement is considered to be downhill. So if the usually if the external environment of the cell is has higher concentrations, usually the inside environment of the cell is the low concentration. So the movement is from higher to lower concentrations. Next, so we have water and pH. So based on the biomedical importance, water is the predominant chemical component of living organisms. So mostly 70, 80% or 60% of the living organisms are composed of water. It is unique physical properties which includes availability to solvate or to dissolve wide range of both organic and inorganic molecules, and derived from water's dipolar structures and exceptional capacity to forming hydrogen bonds. Okay, so when say water is ideal biologic solvent water, so we have usually they are sp3 hybridized, wherein 1s that hybridized with 3p orbitals or pypz. So this is the hybridization state of water is sp3 hybridized, that is tetrahedral. Okay, so water molecules is an irregular slightly skewed tetrahedron with oxygen in its center. Okay, usually we have oxygen, so this is the spare electrons, and we have 2 hydrogen atom. Okay, sp3 hybridized tetrahedron or tetrahedral. Usually water is dipole, a molecule with electrical charge that is distributed asymmetrical. So when you say dipolar, the movement of the electrical charges are not the same. Okay, so based on this structure of water, wherein there is an asymmetrical distribution of electrical charges. Okay, so next, so interaction of water. So this one, most biomolecules are amphipathic. When you say amphipathic, it can act as both hydrophilic or water soluble phase, or hydrophobic phase, or lipid soluble phase, or both polar and non-polar. So they possess rich in charge of polar functional as well as hydrophobic. So meaning mambaka amphipathic, it can act as both, or it possess region which has polar and non-polar, or hydrophobic or hydrophilic, or water soluble or lipid soluble character, or functional groups. So proteins tend to fold at R group of amino acids with hydrophobic side chain. So this one is considered to be the R group or the variant, and this is the general structure of your amino acid. So this is the NH group, the positive charge. We have the carboxyl group, which is known to be the negative charge. So with the hydrophobic side chain in the interior, okay, usually water falls at the R group. So R group, depende sa variant kung ano yung nakakonect dyan o nakaban na uh, uh, molecules, okay, or other functional groups. So the functional groups of amino acid is the NH3 and COH, okay. This is general structure, ha. So R depends on the variant. Okay, amino acids with charged or polar amino acid side chains. So arginine, glutamate, serine are generally present in the surface in contact with water. Okay. So example, association of two dipolar water. So pwede yung water can bond with another water, so they can able to form clusters of 4 water or more than 4 clusters or 10 clusters, because there's a bond between oxygen to hydrogen and oxygen to hydrogen and so on and so forth. So almost the same lang yung bonding. Okay, so usually hydrogen is the donor and hydrogen is also the acceptor.